Good morning, everybody. Welcome to theme 4, which is CHIM, Controlled Human Infection Models. I'm going to give a very quick overview. Actually, before I do, thank you very much to the last two summarizers for getting us back on time. We'll try and stay there. Well, there's some overarching questions in case you're not already bored with them. Right, controlled human infection models. So what is a controlled human infection model? This isn't just a human infection model where you infect people. That's been done lots in the past, especially with malaria therapy for syphilis, neurosyphilis, for example. This is a controlled, the C is very important. A well-characterized strain of an infectious agent is administered at a controlled dose and by a specific route to carefully selected adult volunteers. That's taken from Stephen Gordon's very, very nice summary of a workshop held in Malawi, sponsored by the Wellcome Trust, which is published in Wellcome Open Research. If any of you want to look, it's a lovely summary. So why do this? Well, what it does is it ensures that you get full 100% exposure of the subject to an effective dose of the pathogen. This is useful scientifically for a number of purposes: for investigating pathophysiology, for defining the immune response to a pathogen, for testing drugs, and most importantly, for testing vaccines. This is where it's been most used. And CHIMs have been used to develop vaccines for typhoid, cholera, and malaria in recent years. Not the whole process, but part of the process. And also is accepted by regulatory bodies now as evidence for efficacy of vaccines. So these are you probably can't see this is a list of the various pathogens that have been the subject of CHIMs over the last half a century or so. In terms of numbers of subjects on the right, the most common is enteric fever, so typhoid and paratyphoid, salmonella, and then you've got influenza, malaria, pneumococcal carriage, Shigella, E-tech, that's E. coli, nasty gastroenteritis bug, Neisseria, lactamica, so that's a non-pathogenic strain of Neisseria. Neisseria can cause other diseases, other species. Campylobacter, norovirus, cholera, cryptosporidium, RSV, dengue, and mycobacterium. That's just showing that actually there's a huge range of pathogens that you can be the subject of CHIMs. So I guess what we're talking about here is, why should we conduct CHIMs in LMICs? Most CHIMs have been conducted in developed countries. And I guess there are ethical and social reasons for carrying out human infection models in the countries which are endemic for the diseases, in the populations who are going to be affected by the disease, who are affected by the disease, and who may benefit from a drug or vaccine that might be developed. And then there are scientific reasons. So volunteers from LMICs are, if you like, the natural hosts of the disease. They differ from high-income country volunteers in a number of ways, which can influence the host pathogen and also the host vaccine interactions, if it's testing a vaccine that you want to do. So, and testing a vaccine, of course, you give the vaccine, and then a few weeks later, you give the pathogen to the individual and see whether the vaccine prevents infection. So the kind of areas where these differences between LMIC and HIC volunteers may be important are genetic makeup, previous exposure to the pathogen, and also to other infections which may influence the makeup of the immune response. Immune status of the individuals, worm burden, potentially HIV, etc. For enteric pathogens, the microbiome may be important. You have quite different microbiomes in LMICs, in the gut, for example, and also for pneumococcal carriage in the nasopharynx. And there may be environmental factors too. And very briefly, what are the possible issues? This is not a complete exhaustive list. Issues with conducting CHIMs in LMICs. Well, obviously, goes without saying you need pretty good clinical and laboratory facilities, which may or may not be available. Increasingly, they are available in a number of centres. You need very careful monitoring of the subjects. And of course, you need good governance of the whole process. There may be an inadequate regulatory framework for conducting such studies in LMICs. There may be a number of factors that hamper fully informed consent, such as language, educational level, sort of cultural understanding of germ theory, etc. Does a volunteer really understand that you're going to infect them with a pathogenic organism? Research ethic committees within CHIMs will be unfamiliar, within LMICs will be unfamiliar with controlled human infection models. So that involves an education process and also so that they can consider the relevant factors that will decide whether or not they think it's ethical or not ethical to proceed with a particular CHIM. Then there's things like natural exposure to related pathogens during the study, which may interfere with your experiment. If you're doing a malaria CHIM, for example, and you send your subjects back out into the community, they may catch natural malaria if it's an endemic area, and that will interfere with your statistics, of course, because you're not if you're testing whether or not you get sterile immunity from a vaccine, for example. And also natural exposure to vectors during the study. You may not want this controlled strain out there in the wild. That may not be an issue in HICs, but where you have lots of ADs around, for example, you may not want this controlled strain of dengue getting out there after a Aedes mosquito bites the subject who's been infected. These are just some of the issues that we have to tackle. But to get a